Welcome back to Coronavirus University, my remote lecturing location during the pandemic. I'm Rob Kussner, a professor of math at UMass Amherst, and the course chair for Math 235 linear algebra this fall. I think you've seen this linear system before. Remember, these were the equations that govern the ages of the three young ladies at the post office near where I am now, about 10 years ago. And well, we already observed that m equals 29 is easy to solve for. And we're trying to solve for B and L, the age of the big and little sisters. And what I want to show before solving it, the system, is a nice way of encoding a system in what's known as an augmented matrix. It's an idea that goes back before Gauss. It goes back to China more than 2,000 years ago, and perhaps to Babylon nearly 3,000 years ago. Although, yeah. Anyway, so the idea is that each equation in the system, and I guess this has three equations, so maybe I'll label them 1, 2, and 3, corresponds to a row of the augmented matrix. So there's a row, and I'll also label them 1, 2, and 3. And this augmented matrix has two parts. There's the so-called coefficient matrix, which comes from the coefficients here, and there's the augmentation. So there's the coefficient matrix, and there's the augmentation, which in this case is a single column. Okay, the matrix is an array, and I usually indicate the size of the array by the number of rows by the number of columns. So this is a 3 by 3 coefficient matrix. The augmentation is a column, so I guess it has 3 rows and 1 column. And the augmented matrix has 3 rows and 4 columns. So again, this is the number of rows. This is the number of columns. Rows by columns. Okay. Well, how do we get that matrix? Well, this equation doesn't seem to involve B or L at all, but it really does, right? Because what is it really? It's really the equation 0b plus 0l plus 1m equals 29. So the coefficients here would be 0, 0, 1, and maybe I'll put the augmentation in purple, 29. And how about this one? Well, this one, it's 1b plus 1l plus 0m equals 10. So I should put here 1, 1, 0, and the 10 is the same. And finally, here, what is it? It's 1b minus 1l plus 0m. But be careful, okay? We want to think of these as adding, so this minus 1l should really be plus minus 1l, okay? That's important. Lots of mistakes get made there. So what are the coefficients in the coefficient matrix? It's going to be 1 minus 1, 0. Okay, that minus 1 is the coefficient in the second column there. And that's going to be equal to 4. So the augmentation gets a 4 there. Okay, so each row of the coefficient matrix encodes an equation. Each column corresponds to a variable. So the columns correspond to the unknowns. Okay. And so, in fact, if I remember the names of the variables, B for the first column, L for the second column, M for the third column, then I can completely recover the system of equations from the coefficient matrix and the augmentation, the augmented matrix. Okay, so this encodes the linear system